Good morning students, this is your teacher Neelam Helawat and we'll continue with the chapter, that is chapter number 11, the human eye and the colorful world. Yesterday we talked about the various parts of the human eye and how does different parts perform different functions. Now today we'll talk about the various eye defects. What are the various disorders or defects which are associated with eyes and that decreases your normal power of vision. Okay everyone? So you be ready, keep your books and notebooks ready so that we can start everyone. Let's start. The first defect is called myopia. Now myopia is also called as short-sightedness or nearsightedness. So we have three names for this defect. First is myopia, short-sightedness और near-sightedness. देखिए जैसा word से clear है, near-sightedness. So basically in this defect we can see nearby objects clearly but we cannot see the far object distinctly. हमें पास की चीज़ साफ नज़र आती है, दूर की चीज़ हमें धुंधली नज़र आती है. ठीक है? near-sightedness, पास की चीज़ साफ नज़र आती है और दूर की चीज़ धुंधली नज़र आती है. ओके क्लियर एवरीवन? सो सच अ पर्सन कैन सी ऑब्जेक्ट्स क्लियरली up to few meters. So if the object is very far away from us, we won't be able to see it clearly. पास की चीज़ हमें साफ नज़र आएगी, दूर की चीज़ हमें धुंधली नज़र आएगी. राइट? क्लियर है? Now can you tell me where is image formed in the eyes? Tell me the place where image is formed. In case of human eye, the image is always formed on retina. Image is always formed on retina. But in case of myopia, the image is not formed on retina, but it is formed in front of retina. Right? It is always formed in front of retina. I hope the definition of myopia is clear. In myopia, we can see nearby object clearly, but we cannot see far objects distinctly. Clear? Coming to the causes, why this happens? See, this is because the lens becomes highly curved, or we can say the focal length of the eye lens has decreased. The focal length of the eye lens decreases, thus it is able to see the nearby object clearly but cannot see the far object distinctly. Secondly, the size of the eyeball has increased. Okay, so two reasons for this defect. One is the focal length has decreased, or secondly the eyeball has increased. And this defect can easily be corrected if we use the spectacles made up of concave lens. Okay, so in case of myopia we use concave lens so that this defect can be corrected. What type of convex lens is it a converging or diverging? Concave lens is a diverging lens. So in case of myopia we use concave lens and it is a diverging lens and its focal length is negative. Okay, and its focal length is negative. Let's see the diagram of myopia. Okay, let's see what happens. See, this is normal eye. The first is a diagram of a normal eye. Normally when the object is present very far away from us. So let's suppose the OA is a object and it is present very far away from us. Okay, so light rays will be coming. So when light rays come, they pass it through the lens and they will meet at retina. So image will be formed on retina. Okay, the image will be formed on retina. Clear? बहुत दूर से रेज आती हैं और वो हमारे रेटिना पर मिलती हैं और रेटिना पर इमेज बनती है. This generally happens in normal eye where we have no problem. Second case where we have myopia means we have defect. So rays will be coming, isn't it? when the rays are coming, they are not meeting at retina, they are meeting before retina. So image is formed at this point. Let's suppose this point is O. So image is not formed at retina, but image is formed at O. Okay, the image is formed at O point. Now we have to shift this. तभी हमें जो है ऑब्जेक्ट धुंधली नज़र आती है. अब हमने क्या करना है कि जो इमेज ओ पॉइंट पर बनी है उसे वापस से रेटिना पर ले जाना है. जब इमेज रेटिना पर बनेगी तो वो हमें ठीक दिखाई देगी, ऑब्जेक्ट हमें क्लियर दिखाई देगी. अंडरस्टूड? सो वी गॉट टू शिफ्ट दिस इमेज फ्रॉम पॉइंट ओ टू रेटिना, एंड दैट्स फॉर दिस पर्पज वी विल यूज द कॉन्केव लेंस. विल यूज concave lens. So rays will be coming. This lens will diverge those rays. See, your rays are being diverted, isn't it? So it will divert those rays, right? And see, when we extend these diverted rays, okay, you can say try to see where these rays will meet. So hypothetically we'll draw to this point. Okay, so for us, this point, suppose the object is at this point. Initially the object is at this point, isn't it? But for us now, this lens will create an image at this point. Okay, I'm again repeating, just understand this. Concave lens is a diverging lens, so it will diverge the rays. So rays will never meet on this side. So we will extend them at the back side. So when we extend them, they will meet at this point. So when they are meeting at this point, so image is formed at this point. Clear? Image is formed at this point. So concave lens has created an image at O point, this O point, right? Now our eyes will see this point as an object, and automatically this image will be formed on retina. एक बार दोबारा से समझते हैं. हमारा पॉइंट जो है O डैश वो बहुत दूर है हमसे. तो जब रेज लेंस पर आती हैं, लेंस डाइवर्ज करता है रेज को, तो हम इन रेज को पीछे डॉटेड मिलाते हैं तो वो इस पॉइंट पर मिलती हैं, राइट? जब वो इस पॉइंट पर मिलती हैं तो इस पॉइंट पर उसकी इमेज बनती है. क्लियर? सो ये इमेज किसकी है? ओ डैश की. ऑब्जेक्ट कहाँ पर है? ओ डैश पर. तो इमेज कहाँ बन गई? ओ पर. किसने बनाई है? लेंस ने बनाई है, कॉन्केव लेंस ने. ठीक है. नाउ आवर आईज विल सी दिस ओ. इट विल नॉट सी ओ डैश, इट विल सी ओ, एंड दस image will be automatically formed on retina. Image will be automatically formed on retina. The second defect is just opposite of this defect. Exactly just opposite of it. Right? It is called hypermetropia. Hypermetropia is also called as long-sightedness or far-sightedness. Now, as I said, it is exactly opposite of myopia. मायोपिया में पास की चीज़ दिखती है, दूर की चीज़ नहीं दिखती. अपोजिट ऑफ इट, यहाँ पर हमें दूर की चीज़ साफ नज़र आती है. वी कैन सी फार ऑब्जेक्ट क्लियरली, बट वी कैन नॉट सी नियर बाय ऑब्जेक्ट्स प्रॉपरली. दूर की चीज़ हमें साफ नज़र आएगी, पास की चीज़ हमें धुंधली नज़र आएगी. क्लियर? राइट? एंड सच अ पर्सन कैन नॉट रीड प्रॉपरली, क्योंकि उसकी पास की नज़र कमज़ोर है, उसे दिखाई कम देगा, तो वो पढ़ाई नहीं कर सकता, वो रीड नहीं कर सकता. नाउ द रीजंस जस्ट अपोजिट ऑफ मायोपिया. द फोकल लेंथ विल डिक्रीज, द साइज ऑफ आई बॉल विल ऑल्सो डिक्रीज, एंड दिस कैन ईजिली बी करेक्टेड बाय कॉन्वेक्स लेंस. सो विच लेंस विल बी यूजिंग इन केस ऑफ हाइपरमेट्रोपिया? कॉन्वेक्स लेंस. एंड इन केस ऑफ मायोपिया, कॉन्केव लेंस. सो कॉन्वेक्स लेंस इज अ converging lens, and its focal length is positive. Okay, its focal length is positive. Now see, again I have drawn the three diagrams. First is a normal eye. Okay, first is a normal eye. Clear? So in case of normal eye, the image is again formed on retina. Right? The image is always formed on retina. Clear? So there is no problem in this. Second, when you have a defect, जब हमें ये बीमारी हो गई है, सो हमें पास का नहीं दिखता है, तो हमारी ऑब्जेक्ट जो है वो एन डैश पर मौजूद है. द ऑब्जेक्ट इज प्रेजेंट एट एन डैश. ओके, सो इट्स इमेज विल बी फॉर्म्ड बिहाइंड द रेटिना. Where is image formed? Image is formed behind the retina. Okay, so again we have to shift this image on retina, isn't it? And this shifting is done by the convex lens. So we will have a glasses having the convex lens. हम चश्मा पहनेंगे जिस चश्मे में convex lens लगा होगा. ठीक है, अब हमारी ऑब्जेक्ट कहाँ पर है? एन डैश पर है. So rays will come to this first lens, our glasses. Now this lens will create an image at n. ठीक है, ऑब्जेक्ट कहाँ पर है? एन डैश पर. इमेज कहाँ बन गई? एन पर. तो हमारी आंखें अब कहाँ देखेंगी? एन पर. वी विल नॉट सी एट एन डैश, वी विल सी एट एन. क्यों देखेंगे हम एन पर? क्योंकि हमें दूर का साफ नज़र आता है. ठीक है, सो व्हेन वी लुक एट एन, द इमेज विल ऑलवेज बी फॉर्म्ड एट रेटिना. द इमेज विल ऑलवेज बी फॉर्म्ड एट रेटिना. आई होप यू अंडरस्टूड बोथ द डिफेक्ट्स. ओके, now this is your homework. You try these questions. Okay, you try these questions and let's see how many of you are able to do it. And if there is any query, anything that you feel that you are unable to, they are difficult, please let me know that. Okay, but first, before asking me, you should think over and over. When you'll think, you'll obviously understand each and every question. But even then, if you face problem, you are free to contact me, call me. I'll 100% explain things to you. Okay? Okay, everyone. Bye.